In the last video, I've talked about how an object is actually charged. So in this video, I'm going to explain a few things that I had missed out in the previous video. For example, I had used the word ion in the previous video without mentioning what it really is. So an ion is a charged species formed when an atom has a loss of electrons, a loss or an excess of electrons. So if an atom has a loss of electrons, then the atom will become positively charged. Or in other words, we can say that it becomes a positively charged ion. However, when it has an excess of electrons, when it has more electrons than protons, then we say that the atom becomes a negatively charged ion. So now, how do I convert an atom to an ion? To understand this, we need to look into the structure of the atom again. At the center lies the nucleus, which is positively charged, and the electrons revolve around the nucleus in well-defined circular orbits. And the electrons are negatively charged particles, and the nucleus consists of protons, which is positively charged. So there exists a force of attraction between the nucleus and the electrons. This force of attraction, there's a force of attraction, between a nucleus, an electron, and the nucleus. Now, to convert an atom into an ion, I will need to overcome this force of attraction because the electrons are already bound to the nucleus due to this force of attraction. Due to this force of attraction, the nucleus is already bound to the electrons. So I will need to exert a little more force. I need to expend my energy to take out an electron from the area of influence of the nucleus. Now, there's something which you might notice, that this shell, this valence shell, I talked about the valence shell in the previous video. The valence shell is the outermost shell of an atom, and the electrons that are present in the valence shell are called the valence electrons. And the most interesting thing to note about the valence shell is that this is the shell which is farthest away from the nucleus. As a result, the electrons present in the valence shell are not so tightly bound. The electrons present in the valence shell are not so tightly bound. To the nucleus. As a result, it is very easy to remove this electron from the area of influence of the nucleus. So an ion is usually formed when an electron enters into the valence shell or an electron is taken out, pulled out from the valence shell, because that is the shell which is easiest to attack for transfer of electrons. So the process of conversion of an atom into an ion by providing energy to an electron. So, by providing energy to an electron, we actually raise the energy of the electron. And as we raise the energy of the electron, it comes out. We can pull it out from the area of influence of the nucleus. So, the process of conversion of an atom to an ion by providing energy to an electron is called ionization. So why I wanted to define ionization to you was that the next thing that we are going to learn, the methods of charging. The first method of charging is called charging by rubbing. You must have often experienced that when you rub a piece of synthetic cloth on your belly or on your chest, then you can see the hair on your belly or your chest rising up. That is because of static electricity. So I'm going to explain to you why this happens, and I'm also going to introduce charging by rubbing. So to understand charging by rubbing, it was essential to understand what ionization actually was. So, how do I charge by rubbing? How do I charge by rubbing? It's a very self-explanatory and the answer is actually present in the question. By rubbing, of course. But why does that happen? To understand that, let's see what happens when you rub a material against another. When you rub a material against another, rubbing leads to friction. And friction, as you all know, it's a force which opposes the force which you are applying. So we need to expend more energy. We need to expend our own energy to overcome the force of friction. Now, to overcome the force of friction, we need to expend our own energy. Now, you might remember that energy can neither be destroyed and can neither be created. However, energy can be conserved. So this energy which we expend is actually provided to the electron. This energy is provided to the electron. This energy is provided to the electron, which helps us to pull it out from the area of influence. From the area of influence of the nucleus. Thus creating an ion. And ions on a whole, on a large scale, a lot of ions, a lot of positively charged ions, for example, together leads to positive charge in the body. This is how we can charge an insulator by rubbing. So, that's all for this video. Thank you very much.